Hey everybody, Dr. Burks here. So this week we're doing a lab where we're going to determine the rate law for a reaction involving crystal violet. So crystal violet, I've abbreviated it here as CV+. The full structure is shown out in your lab manual. It's a kind of complicated structure. I didn't want to draw it all, so I just wrote it shorthand up here. So we've got our reaction between crystal violet and hydroxide, and we're going to form a product. And so we're going to determine the rate law for this reaction. So remember the rate law from kinetics, our rate is equal to K, which is the rate constant, times the concentration of crystal violet raised to some power m. And m is the reaction order of crystal violet, our reactant, and then times the hydroxide concentration raised to some power n. N here is the reaction order of hydroxide. So in this reaction, we're going to be measuring or determining what K, M, and N are in this rate law equation. Right? So K and N, after we get all of our data, we're going to make some graphs. We're going to get M from our graph. We'll get K and N from some calculations once we have our M value. Right? So we'll be able to determine K, M, and N, which will then go into our rate law equation. And so crystal violet is a purple solution. Our product is a colorless solution. So what we're going to do is we're going to measure the color, basically how much purple there is in the solution. And as this goes down, the color will also go down as well. And that's how we're going to measure the concentration of our crystal violet throughout this experiment. So let's go ahead and get started.